Hello, my name is François Philippe. I work here at LabVolt in the Quebec City plant. I'm an instructor. I'll be presenting a quick overview of the 3400 refrigeration system demonstrator. This system is intended to be used as a demonstrator for teaching typical elements of a refrigeration loop. All the very basic components are included, and on top of that, there's an introduction to heat pump. So first, let's start with just following the different components throughout the system to see what they are and how they are used. So let's start here, well, with the compressor, typical element of a refrigeration loop. At the outlet of the compressor, we have a pressure indicator, high pressure indicator because we are at the outlet, so we should have hot gas at this location. If we follow the copper tubing up here, it goes up to this location where we have a four-way manual reversing valve. You may have seen four-way reversing valves in heat pumps. Usually they are all automated, meaning that you don't have to do anything. They will just switch the path of the refrigerant by themselves automatically, depending on if you would like to be in winter or in summer condition, or if you prefer heating or cooling solution. In that case, we have used manual valves, so the students have to get a good understanding on how the four-way reversing valve is used. So for example, I'm in the outlet of the compressor. I would like to use this coil as the, for example, outdoor coil, so where I would like to reject my heat to the surroundings. So what I would have to do is open this valve. So if I open this valve and I make sure that this one is closed, the refrigerant has to go in that direction. So it will go throughout this coil here, which is now the outdoor coil. You can see probably that we have, well, it's not obvious on the screen, but we have transparent coils, partly transparent. This is to make sure that the students will be able to see the phase change as we go from a hot gas. And well, since we are using this coil now as the condenser, it will condense to a liquid as it travels through this coil here. So at the very top you wouldn't see anything because we are still in gas form, but as you travel throughout the coil, at the very bottom you would see mostly liquid refrigerant, which is very interesting. At the outlet of this coil here, you still have a pressure indicator. You have a filter dryer, typical component again to remove dirt and moisture. You have a side glass which allows you to see if the refrigerant is flowing, and depending on the color code that you have, it will tell you if it is wet, dry, or if you have to be cautioned because it could be becoming wet. Also, if there's oil in the system, you would be able probably to see a bit of it through the side glass. After we've been through the condenser, through the filter dryer, well, the next step would be to choose an expansion device. In this case, we have a choice of expansion device. For example, we have a typical thermostatic expansion valve. Also, we have capillary tubes, so this one or this one here. This is just to give you the opportunity to show what's the difference when you have thermostatic expansion valve as opposed to a capillary tube. At the outlet of the capillary tube, well, you will have to go through another filter dryer, and then you will go through the other coil. If this one was the condenser coil, then this one means that it is the evaporator coil. It goes from the bottom, travels all the way up, and you will again be able to see the phase change. Since this is the evaporator, it means that it goes from a liquid form mostly up to, at the very end, at the top, it will be mostly gas. So it will absorb heat from the surroundings, which is, well, inside this box here. So at the outlet of the evaporator right here, you will have to go back. If this valve is open, you'll have to go back to the input port or the low pressure port of the compressor, and the cycle goes back again and continues. How are we able to modify the conditions? You don't want to have fixed conditions. You want to be able to vary the load or to vary the environmental conditions of the system. So there are several ways to do that, but one of them is using this. You can see with the light changing. Let me move out of the way. Right here. So this is this is kind of a damper. It allows more or less airflow through the system. So this is one way of changing the conditions in the system. Also, it's possible to vary the fan speed with the fan speed button. We have an indoor and an outdoor fan. Also, it is possible in the system to insert different faults. So there are 6 different fault switches on the panel here, and the student would have to troubleshoot and find what's wrong with the system. Also, there is a thermometer, and we supply with this thermometer probes that you will be able to attach at different locations in the system. It will allow you to measure temperature at key points. So typically in a refrigeration loop, we'd like to be able to measure the temperature at the inlet and outlet of the compressor. We'd also like to be able, obviously, to measure the temperature inside, for example, the condenser or the evaporator. So these would be locations of interest for temperature measurement. In the manuals, it covers the basic refrigeration cycle. So all the components it covers are common to most, if not all, of the refrigeration systems. It doesn't matter if it's industrial or residential, the basic components are always the same. So the 3400 is really a good introduction for learning the theory about a loop, and most of all be able to see really what's happening, which is a key element of this system. Usually you are told that there's a phase change, but you never really see it. In that case, it's possible to see it. Now, the document I'd like to be looking at right now is the datasheet. This document is available in our website, or you can have it through your dealer easily if you don't already have it. So I'm going to concentrate on one part of this document, which is here, the Courseware. So there are 3 different manuals that are supplied with the system. We have the student, the instructor guide, and also a user manual. In the user manual, you have all the steps that will help you prepare the system so that it'll be usable by students. In those steps, you'll have to make sure that the system is charged with refrigerant. Usually this is done with a specialist. It cannot be done by anyone that has not proper qualifications because refrigerant has to be handled in specific ways. If we go to the topic coverage, since this system is intended to teach the very basics of refrigeration, we start with basic physics. For example, we talk about heat and heat transfer, pressure and temperatures. Well, why do we talk about heat and heat transfer? Mostly because a lot of people, if you ask around you, you'll notice that people have been somehow misled to believe that refrigeration is about creating cold. Well, it is not really that. It is really about moving heat from one location to the other one. So that's why we talk about heat pumps sometimes when we refer to a refrigeration system. So a great deal of attention is about pressures and temperatures. Well, this is required if you want to be able to understand what's happening within the condenser, the evaporator, the thermostatic expansion device, or the capillary tubes. If you want to be able to understand the reasons why pressure is at that level and temperature at that level when you are, for example, at the outlet of the compressor, well, you have a high pressure and high temperature. So you have to understand the relationship between pressure and temperature for a system which is at constant volume basically. So the refrigerant is stuck inside the pipes, and this will determine the relationship between pressures and temperatures. Introduction to refrigeration, the second topic, the basic refrigeration system. So here they introduced compressor, condenser, expansion device, evaporator, and back to compressor. So the really basic system. And then additional refrigeration device, well, they introduce devices that are not always present but are useful to refrigeration systems. The third topic is about the compressor. It explains how the compressor is used. So it's not only about the refrigeration cycle itself, but it tries to explain all the different components, how they work, and how they are used in a typical refrigeration system. So this is true of the compressor, evaporator, condenser, metering devices. And another point of interest is the system control device. Well, often you will have pressure controllers that will decide when the compressor will start and stop, for example. Once we have covered the basic physics of refrigeration, basic components, and explain how they work and why they are there, we go to introduction to heat pump systems. So this is what I was talking about when I shown you the manual four-way reversing valve. So this is just to introduce to students that when you want to switch between heating and cooling a house, for example, well, you don't have to have two separate devices. It can be done just by switching the flow path of the refrigerant through the system. So this is pretty interesting. And to finish, we have refrigeration faults. So as I've shown earlier, well, there are 6 faults in the system, and the idea is to have students troubleshoot the system. And how are you going to troubleshoot the system? Well, in refrigeration system, there are really 3 parameters you can follow: pressure, temperature, and, well, the electricity within the different controlling devices. So these are the 3 ways you will be able to troubleshoot the system. So that's why they talk about electrical faults and compressor and pressure controller faults. So you can talk about 2 different types of faults. So this is the content of the student manual. The instructor guide includes answer keys to that and some comments as well.